Let's continue with example 5 in our lesson 3-4. Check whether x minus a is a factor of p of x. How can you use the remainder and factor theorems to determine whether the given binomial is a factor of p of x? If it is a factor, write the polynomial in factored form. So remember that remainder theorem says that if a polynomial p of x is divided by x minus a, the remainder is p of a, and we explore that. We use that in example 5. In this example, we're going to use the factor theorem that comes from the remainder theorem. So the factor theorem states that x minus a is a factor of polynomial p of x if and only if p of a is equal to 0. So how do we check if it's a factor of polynomial or not? If it has a remainder that's 0 or p of a is equal to 0, then it's a factor. So look at part A. We have p of x and we have a binomial x minus 0. Using synthetic division, we see that the remainder is 0. That means p of 6 is equal to 0. And using the factor theorem, we know when p of a is equal to 0, it is a factor. X minus a is a factor of the polynomial. So x minus 6 is going to be the factor of polynomial p of x. Okay, so let's look at another example, part B. P of x is x to the 5th power minus 5x cubed plus 9x squared minus x plus 3 and binomial x plus 3. So your a here is negative 3, and then you use synthetic division to figure out the remainder, which is negative 21. So p of a is equal to p of negative 3, which is equal to negative 21, which is not 0. So if it's not 0, then it is x minus a is not a factor of the polynomial p of x. So there we go. Negative 3 is x plus 3 is not a factor of polynomial p of x. Okay, so using the factor theorem that comes from the remainder theorem, we can easily check if this is going to be a factor or not, a good factor, a complete factor, right? Is it still divisible? Yeah, even if there is a remainder, we can still divide it and have a remainder, but we're not talking about if it's divisible or not. We're checking if it's divisible completely and if it's a factor of the polynomial. So when you have a remainder of 0, then we can say as a factor. So let's look at try number 5. Use the remainder and factor theorems to determine whether the given binomial is a factor of p of x. You have part A and part B with the polynomials given and the binomials for each corresponding polynomial. So pause the video, check if you can solve it by yourself, and come back when you're ready for answers. Okay, are you ready? Yeah, before we move on, I just want to make sure that you know what each theorem is. Remainder theorem. So remainder theorem says that if a polynomial p of x is divided by x minus a, the remainder is p of a. Okay, and using this, we know the factor theorem is also valid. So x minus a, the expression x minus a is a factor. Let me put a parentheses. Is a factor of a polynomial p of x if and only if P of A is equal to 0. Okay, so now we can check if the remainder is 0 or not. So let's look at part A. Use A is equal to 4, right? So 4, using synthetic division, 1, negative 10, 28, negative 16. You'll put 1 down, multiply by your factor, your 4, your A, and then you add them, multiply, add them, multiply, and you have a remainder of 0. So yes, it's a factor because the remainder is 0. The remainder is 0. So x minus 4 is a factor of P of x. Okay, so this is for part A. Okay, what about part B? So part B, you're going to use A is equal to negative 5, and then use synthetic division, 2, 9, negative 2, 6, and negative 40. Put 2 down, multiply, and then add, multiply, and add, multiply, and add, multiply, and add. So remainder is not 0, so this cannot be a factor of P of x. The remainder is not, so is 5, not 0. So x plus 5 is not a factor of P of x. Okay, there we go. So check your answers and see if you got it right. If you didn't, please look back in your own work and see where you made the mistake. Okay, let's wrap up our lesson. We looked at dividing polynomials and ended with the remainder theorem and the factor theorem. So in the beginning of the lesson, we talked about long division and synthetic division. And so using long division, you can use any polynomials to divide them, and whatever is remaining, you can write it as a remainder. And synthetic division is a method where you can save a lot of steps. So, writing down your variables. So using your coefficients, you can use synthetic division. And either method should give you the same solution. So you can write your remainder as plus 6 with your factor being multiplied to your divisor. So we also have the remainder theorem and the factor theorem at the end. Remember that if a polynomial is divided by a divisor x minus a, the remainder should be equal to P of A. So the remainder 5 is equal to P of 5 as well. And using this theorem, we can also conclude that the factor theorem works too. So the binomial x minus a is a factor of P of x if and only if P of a is equal to 0, because then that means we have a remainder of 0. So that it's a factor. Okay, so that was our lesson on dividing polynomials 3-4. I'll see you in the next video. Bye!